Hi, everybody. It is week 3 in basic chemistry, and we're going to talk a lot about the periodic table this week. And really, this is one of my all-time favorite weeks in the entire course because we're going to talk about family trends. In the same way that everybody in your family might have brown hair and brown eyes, maybe everybody in your family has great musical talent, or everybody in your family is good at golf or is really superb at playing bridge, whatever it is, there are family trends in human families. The same thing is true on the periodic table. If there is a family called the halogens or the noble gases or the coinage metals, there are trends that those elements have in common. And if you understand the properties of the family, you know an awful lot about all the elements in that family. And that's what we're going to talk about. Now, this chapter is going to be different than the last two. It's going to be less about skills for you to learn. On the study guide, there are going to be some things you have to pull off the periodic table, but this is going to be much more descriptive. So the videos are going to be a little bit longer, but the questions are going on the study guide are going to be less you scrambling to find information and picking things out. It's going to be a little less problem solving and just a little bit more grab the popcorn, sit back, relax, and listen to the stories about the differences between a halogen and an alkali earth metal. Because once you get the trends on the periodic table, boy howdy, it's kind of fun, and I really love this. So let's take a trip over to Canvas and see what we're talking about. We're going to start with isotopes, and isotopes are different forms of the same element that have different weights, and we usually refer to them by their mass. So I'm really happy I don't have to introduce myself and say, hi, I'm Mary at pounds. I'm really glad we don't do that, but that's the way atoms work. Different forms of the same element, we usually put their weight right behind them. Yeah, I'm glad I don't do that. But that's how we differentiate different forms of these pure elements, and those are called isotopes. As always, there is your PowerPoint notes. Again, if you haven't gotten into that habit, please do. And this is the last time I'm going to mention it because you know how to find them right there. The textbook sections, there's not a lot this chapter, primarily because this is descriptive about different families on that periodic table, but we are going to talk a little bit about radioactivity. And so there's only one section in that online book that's really going to provide some good background information about isotopes right there. Then we're going to go off to our study guide, and our study guide, as I mentioned this week, is a lot more questions about the information from the videos. So the videos are your big source of info usually, but much more so this week. Radioactivity, metal families, group 1 and 2, and then we're going to go over to the transition metals. We're getting into non-metal families, the halogens, the oxygen family, and different topics and trends through all of those. After we go through the study guide, or after you've downloaded that, and remember you're going to fill that out and submit it for a grade, we're going to talk about radioactivity. Radioactivity is something a lot of people do not understand, and a lot of people are frightened of it. It is natural. It's all around us every single day. There are radioactive atoms in your body, in your desk, in your computer, in your paper, in your pen. Mankind did not create this. We discovered it. And you cannot sense it with your eyes and your ears and your body. You don't know it is around you. And that's why it was only a little over 100 years ago that we first discovered it at all with the Curies and the Becquerels, that they actually determined that radioactivity existed. So we're going to talk a little bit about it and some of the hazards. Please watch these extra videos about half-life and uses of radiation. Radiation can be used to do a lot of really cool things. I know many of you are going into medicine. You may not be aware that many of the medical supplies you use on a daily basis in the healthcare system are sterilized using radioactivity. It is an efficient, fast, and incredibly wonderful way to sterilize gauzes and packagings and drapes and wraps in the package. If you think about it, a lot of these things are manufactured just in a plant with people like you and I who are dressed in blue jeans and t-shirts. and the next time the package is opened is in a surgical suite, how do they get them sterilized in between? Well, they expose them to high levels of gamma radiation, and that gamma radiation kills fast-growing cells. What's fast-growing cells? Bacteria, viruses, fungus, and mold. And those are the nasties that can cause infection in patients. So pretty cool stuff. And like all things, if it's used well, it can be helpful. Used wrongly, it can be dangerous. We're going to go into some big discussions about the metal families and their reactivity trends, depending upon where something is on the periodic table, can determine if it is highly reactive or less reactive. So we're going to go through those. Here are some demos of sodium in water, potassium in water. When I do face-to-face classes, I love showing these demos. We're not face-to-face with each other, so please watch these. We'll talk about the alkaline earth metals, and then one of the alkaline earth metals with water, and then calcium in water. And you don't think of calcium as a metal, but it really is a metal. And this is a metal that you actually have in your bones, which is one of the reasons your bones are nice and strong. Then we will go on to the transition metals, which make up so many of the colorful compounds. If it's colorful and natural, odds are it's got a transition metal in there somewhere. And I love color and art and anything like that. So I love the transition metals. Non-metal families, these are the upper right-hand corner of that periodic table. We'll talk about the noble gases, the halogens, good disinfectants, oxygen family, oxygen, sulfur, good disinfectants, good bleaches, and that will finish off our march across that periodic table. And then we'll have our quiz. Our quiz is a few more points, not a lot more time, a few more minutes because it is more questions, but it is mostly information that you're going to pull out of your notes. So I think you're going to have a fun time this week. It's great stuff. Difference between calcium and magnesium and sodium, and I love it. It's a great week. One of my absolute favorites. Have a good time, and we'll talk to you soon. Bye-bye.